Question 7. What will be the final volume of a 425 ml sample of gas, initially at 22 degrees Celsius and 760 millimeters of mercury, when the temperature is changed to 30 degrees Celsius and the pressure is decreased to 360 millimeters of mercury? There's more numbers in this one. We're going to apply the same strategy though. Make a table. Organize the information. 1 and 2. First number, 425 milliliters. And it says a volume of, so that's a volume. The unit milliliter tells us that as well. 22 degrees Celsius. What do we need to do to that? Convert it to Kelvin. So we're going to add 273. And that's 295 Kelvin. That's a temperature, so we label that column T. And 760 millimeters of mercury. That would be a pressure. The next number we come across is 30 degrees Celsius. So we want to put that in the same column as the other temperature. So 30 degrees Celsius, and then we have to change that one also. So that's going to be 303 Kelvin, right? 273 plus 30, yeah, 303. And the pressure is decreased to 360 millimeters of mercury. And now I've got all my numbers out of that, and I have a blank. That'll be V2. The question is asking what will be the final volume. So that's good. Now these units in this table, here we've got milliliters, and in some of the problems we convert to liters. Do we have to convert this here? No, we don't. Here our pressures are in millimeters of mercury. They're both the same. That's going to be okay. Temperature always has to be in kelvins. And when we get to the ideal gas law calculations where we just have PV equals nRT, then we have to be particular about all the units, but not here. So this one is one where we have all three variables changing, and that's where we use this combined gas law. So P1 V1 over T2, no, T1 equals P2 V2 over T2. Again, we're going to cross multiply to get rid of the nasty fractions and just make it a lot easier to deal with. So we're looking for V2. So that means we have to divide by T1, so those cancel out, and we divide by P2, so those cancel out. And then it's like dealing with two little boys and you're giving them cookies. If you give one 2 cookies, you have to give the other 2 cookies. So if we divide one side by T1 and P2, we have to divide the other side by the same things. And that makes sure that it stays equal. So now we copy this down, and with all these letters and numbers, it's really easy to get them mixed up a little bit. So after you copy it down, double check it and make sure that you didn't move a 1 or a 2 or change a P to a V or something. Now we fill these in from our table. Pressure 1, 760 millimeters of mercury. Volume 1, 425 milliliters. Temperature 2, 303 Kelvin. All of that divided by temperature 1, 295 Kelvin. And pressure 2, 360 millimeters of mercury. So when we have all this laid out in the table, we're just finding, oh, I need to find P2. I go look in the table, oh, there's P2. It takes a lot of the confusion out of it. We'll check our units, millimeters of mercury cancel out, kelvins cancel out. Now just be careful when you do this on your calculator. Anytime you've got two numbers in the denominator, got to be careful. This is how I do it and how I recommend that you do it. 760 times 425 times 303 divided by 295 and then divided by 360. And I come up with 922, and the unit will be milliliters.